can identify an arithmetic and geometric sequences. So we already introduced functions the first semester. We've been working with functions all year with reviews and stuff like that, but today we're going to look at a different approach to those. So what are arithmetic and geometric sequences? Arithmetic and geometric sequences are a list of numbers. In parentheses, we wrote each number known as a term. Write that down. That often form a pattern. And the pattern is called, it's in parentheses, known as a common difference or a common ratio. Examples. Let me show you some examples. Here's two sets of lists. One of them is 1, 5, 9, 13, 17, 21. The other one is 1, 5, 25, 125, and 625. Copy that, and then we'll go over it. All right, let's see. So it says, a list of numbers. Do we have lists of numbers? Yes. Each number known as a term. So check this out. This list has 1, 2, 3, 4, 5, 6 numbers. Therefore, this has 6 terms. Let's look at this one. 1, 2, 3, 4, 5 numbers. Therefore, this is how many terms? 5. Okay. So, pens down really quick. Look up. So let me go ahead and go through the definition and go through each one of these to make sure we got what we're talking about. So we know that each one of these numbers are known as terms. We have 2 lists. I'm going to switch to red. I'm going to go over the first list. And I see that there's a pattern for this list. And the pattern that's shown is that it's adding what? 4 to each of those numbers. Okay? Whenever you have a list of numbers, and there's a number being added or subtracted, listen to what I'm saying. Whenever you have a list of numbers and whenever there's a number being added or subtracted, that list is known as an arithmetic sequence. Arithmetic sequence. Now, once you identify that it's an arithmetic sequence, this number that's being added or subtracted, that's known as a common difference. And the letter that they use for that number is the letter D. I use quotations so that you can see that I'm referring to this. So that's that. I'm going to switch to blue now. Now, let me look at the second list. And I see that there's a pattern from here to here, which is what? Multiply times 5, times 5, times 5, and times 5. Focus, please. So, whenever you see a list of numbers, and it has a pattern where they multiply or divide. When they multiply or what? Or divide. That's no longer an arithmetic sequence. When they multiply or divide, it's known as a geometric sequence. Geometric sequence. And that number that's being multiplied or divided is known as a common ratio. And guess what variable or what letter they use for that? R. The letter R. Is everybody following so far? So according to the definition, it makes sense. List of numbers, yes. No, each number is known as a term, yes. This one has 6 terms, 5 terms. And the pattern, when it's an arithmetic sequence, known as the common difference, letter D. When it's a geometric sequence, is known as a common ratio, letter R. Yes? Oh, very good question. Look at the none example. Copy this, please. Copy that sequence. And see if you can find the pattern. Find the pattern and find out what it does. Don't say it out loud. Let people think. Copy that, and then I'll go over it. All right, I'll take a volunteer for the pattern on that one. Go ahead, Dallas. Dallas says add 2, then multiply by 2. Let's see if it works. Add 2, multiply by 2. Add 2, multiply by 2. So, talk it over with your neighbor and let them know why this is not an arithmetic or geometric sequence? Why is that not one or the other? Okay, so did everybody understand that it has to be consistent throughout, whatever the operation and the number? Okay, look up, please. So I heard you guys that it can't be both. I understand that. But the key word here, it has to be consistent. So here it's consistently plus 4. Over here it's consistently times 5. Cannot be switching back and forth. So, and this one does switch back and forth. Therefore, what are the critical attributes? What is the first thing that you know that has to be consistent? Very good. So write that in the critical attributes. Consistent. And also, what is the other thing that they have in common? Look at these two. What do they have in common? That they are what? List of numbers. Very good. List of numbers, and it's a consistent pattern. Bam. Thank you. Yes. Yes. Yeah, we'll get to those. The other question was, what if they use both operations for each set of numbers? There are sequences like those, but today we're not going to focus on those. We're going to get to those later. Okay? That, what if, you know how we used to do the tables, and I gave you guys inputs of x, get outputs of y, and sometimes it was 2 times x plus 1. They're doing two things to the same number. That's what they're saying. Copy these steps, please. 4 steps. It says, identify the pattern, which means identify the difference or the ratio. Step 2, define whether if it's an arithmetic or geometric sequence. From there, you're going to write the formula and substitute the values. And at the end, you're going to simplify. Simplify. Can you just say define sequence? Yeah, define if it's arithmetic or geometric. Copy that. We got the 4 steps? All right. So, let me go to the next step. So, I need your full attention, please. Let me forward this a little bit faster. All right. So, this form that I'm about to show you is called a recursive form. So, the notation is going to be a little bit different from what you've seen before. So, stay focused, please. Here we go. So, the first one I'm going to show you is arithmetic sequence. Now, what do all these variables and numbers mean? Let me show you. The A stands for the number in the sequence, like the first number. Let's say it's number, or let me show you. Here's the second one. So, for example, let me show you the sequence here. This is 9, 13, 17, 21. Don't copy this. Pay attention. So this tells me that it's the first term. So this A stands for the number, and the little 1 stands for the term. This is the first term. This is the second term. This is the third term. This is the fourth term. So this one is asking for which term? First, because it's right there. So what would be A to the A sub 1? 9. So that would be A sub 1 equals 1. So let me show you how this works. Watch. A sub 1 equals 9. So now we have 1 term, 2 terms, 3 terms, 4 terms. So I want to find the second term using this notation. Now first I need to find out what if this is an arithmetic sequence, I want to find out what the difference is. So let's see. What's the difference from here to here, everyone? 4. We're adding 4, adding 4, adding 4. So my D is 4. Are we there? So now check this out. So in order for me to find the second term, I'm going to write A sub 2 because I'm trying to find the second term. Follow along, please. Pay attention. Stop writing. And then I write A sub, instead of N, what did I write? 2. So this is 2 minus 1 plus D, which is what? 4. A sub 2 is, what is A sub 2 minus 1? A sub 1 plus 4. What is A sub 1? 9 plus 4. Therefore, A sub 2 is 13. Okay, thank you.
You misspelled form. You put
from. I did that on purpose, if you're paying attention. All right, here we go. So that one is if I wanted to find the second term. But in this case, I already have the second, the third, the fourth. I want to find which term? The fifth. Let me show you how to find the fifth. I'm going to write, instead of writing, look, I was trying to find the second term, so I started with A to the first. So now I want to find the fifth term, so I'm going to start over here with A to the what? To the fourth term, which is 21. Let me go, pay attention please. If I was trying to find the second term, I started with which term? To the first, because it all depends on what we do to the previous number to get the next number. So now if I'm trying to find the fifth term, I start with which one? To the fourth term. So let's rewrite this. So this is A to the fifth minus 1 plus 4. A to the fifth is A to the sub 5 is A to the sub 4th plus 4. A to the sub 5th is, what is A to the sub 4th? 21 plus 4. Therefore, A to the sub 5 is 25, and that's how we get that term. Everybody see what we're doing? Okay, copy that, and this is example Q. Copy that, please, and then I'm going to go over the geometric sequence.
Are the questions on the... What?
Yes.
Are the questions on the home plane like this?
Yes. Copy that, please. All right, so I showed you how the formula for arithmetic sequence works with one term going to the second term and to try and find the fifth term. So now that we know the fifth term, I want you to find me the sixth term using that notation, please. Go. All right. So, check this out. Here, we want to find which term? So, on the second line, you should have written A to the 6th, right?
Yeah.
But to start, we need to start with A to the what? 5th equals to 25. Therefore, this becomes A to the 6th minus 1, and at the end, plus the difference, which is 4. A to the 6th is A to the 5th of A to the, A to the sub 5th plus 4. A to the 6th is 25 plus 4. A to the sub 6 is 29. Hands if you got that. We got this, right? Yeah. All right, so now that we have the arithmetic sequence, let me show you the geometric sequence. Pens down, eyes up here. Here it goes. Notice the formula for the geometric sequence. We start off with the same thing. The previous term is here. And the formula is very similar, except for instead of adding the difference, here we multiply the what? The ratio. Does everybody see that? So watch. Look up, please. I'm going to find the next term in this sequence. Look up, please. So check this out. How many terms do I have? 1, 2, 3, 4. And what is my ratio here, everyone? Times 4, times 4, times 4. So R is 4. So now I want us to find the fifth term. So what do I write? A sub 5th, but where do I need to start? A sub 4th is what? 64. So then I write my formula. A sub 5th is the same as, what was the ratio? 4 times A sub 5th minus 1. A sub 5th is 4 times A sub 4th. A sub 5th is 4 times, what was A sub fourth. 64. Therefore, A sub fifth is 256. Ever see how this is working? And that's pretty much the home play for tonight. You just need to find the pattern using the notation. Except for, in the book, they're using a function notation. I don't know if you guys noticed number 9 and 10 on the final, they use f of n, right? So let me show you how that works. Now, any questions with this? Yes? Yes, both ways, geometric and arithmetic. So, let me show you how it's going to be written in the home play. Look up. Instead of writing it like this, the first term, instead of writing it like that, it's going to show like this. Everybody see that? So therefore, this becomes what? F of n equals f of n minus 1 plus d. So therefore, this is what? F of 1, and this one is what? F of n equals r times n minus 1. And that's how it's going to be presented. That's the only difference. But I wanted to show you first with simple variables like these before I use the f of n, because I know f of n could be a little bit confusing. Does everybody understand? Everybody got it? Show me with your fingers how comfortable you are with these. 1 being the lowest, 5 being the highest. Got some 5s, some 4s, 5 4s, 4.5s, 3s. Okay? Huh? They go like this. Anyways, home plate for tonight is on page what? 217. Enjoy your home play, everyone. See you guys tomorrow.